Chairs don't do that in real life. Or do they? This should be a pretty straightforward project. All I need to do is take some poorly constructed furniture and find a way to nudge it into an explosive state. I've been thinking about how the people in Elden Ring reset the furniture so fast.
I don't think that's true, Captain.
I think I've found a very elegant solution to the Elden Ring exploding furniture problem. Is it a problem? Did I make it a problem? Anyways, let's go through them one by one, top to bottom. My first idea on the list is an electromagnet combined with a spring. On one side of the furniture, you're going to have a spring and electromagnet. On the other side, you're going to have a steel plate. Once you turn that electromagnet on, it should pull the steel plate in, compressing the spring, and then when you turn it off, they should explode away from each other. We have to make sure our electromagnet can actually support the weight of the furniture. So we're going to test that first. Okay, so I've assembled this electromagnet to this angle bracket here, and I've put a piece of steel, a piece of wood over here, and when we turn the electromagnet on, bring the piece of steel close, just like that, you can see it sticks, and it sticks pretty well. Like, you can really flip this around and it doesn't come off, so that's good. And then when I kill the power to the electromagnet, the plate disassembles itself, so that's ideal. So let's get to scaling this up. That brings me to my next point. Now that we've confirmed that our electromagnet can support the weight of the chair leg, we can go and build our own fake chair. Yes, a fake chair to start off with. Why are we building a fake chair? Well, primarily because we can control all the variables involved with it. We can make those joints very, very square to each other, which is very nice in this case. And secondly, who doesn't want a fake stool? That's not the reason at all. Okay, so what I've actually done is I've put together this little 3D printed model. It's got mouse traps on either side and electromagnets in the corners. Let's try it out. I'm gonna take this. Essentially there's a plate here, and there's a plate here, and they're gonna couple kind of like that, and then if everything goes well, the mouse traps will spring the leg off in this case. Get the first one in place, and we get the second one in place. Oh my God, who designed this? Then we'll put this up here like that. Oh God! Oh baby, that's spring loaded. It only took, I wasn't keeping track of time, it took about a minute to set one leg. So let's see how this goes. 3, 2, 1, wait. Safety first. 3, 2, oh, now you can't see it. All right, I'm just gonna be off camera for this. 3, 2, 1, go. Well, that didn't really work as expected. I think I need the spring to really impact the furniture at full force, kind of like this, rather than just pushing it out of the way. So of course this thing just fell off. I already tried a whole bunch of different other spring related mechanisms as well, and those didn't really work. The R&D involved to make something of that magnitude work would have taken weeks and weeks and weeks, so I didn't want to do that. Let's move on to the next idea. The good old air piston, or pneumatic piston. Simply give it some air, and the rod extends. What could be easier? So we have our air piston here. That's gonna knock this leg down. It's all gonna be controlled by this guy right here. All right, here goes nothing. 3, 2, 1, go. I'm so close. Reset. Test number 2. 3, 2, 1, go. Worked pretty well. And fall over though, but it did something. While I do really like this idea, I think it gets a little bit bulky. Each leg would need one of these pistons that aren't cheap, hose to a valve over here that's then actuated by a power supply. Not to mention, this is our compressed air hose that runs all the way back to our air compressor right here. So that's a bit of a problem too. Gotta figure all those things out. So on to the next idea. Our next test is the compressed air rocket nozzle. I don't think this one's gonna work. 3, 2, 1. Eh. I could make this thing work, but honestly it's going to take a lot of effort to do it, and then we're just going to be in the same situation as the piston itself, where I have to run hoses and valves and all of that stuff. So I'm just going to move on to the next idea. Do hobby rockets count as explosives? Well, today they do not. The way I'm going to make this work is I'm going to take my old bench prototype, I'm going to put a rocket right here, I'm going to fasten it to the base with magnets so that it's just lightly stuck together, and then I'm going to light the rocket and see if it can launch the leg into space. Hopefully not space though, we don't want it to go into space. 3, 2, 1. Tree. Oh man, okay, that worked well. Let's look at it actually. What happened? There's the, oh, there's the actual rocket itself. It was held in with hot glue.
Oh, I can't wait to have someone sitting there.
Yeah, I don't want to go to a bigger rocket. That was, a few things wrong with that is it was A, too noisy. If I went up a size with another rocket, it's going to be, it takes some of it away from it when you have this huge trail of fire coming out of your chair that's supposed to just explode on its own. Like, we may as well just get black powder and then set the charges in between the joints and just have that explode. But that's not, that's, again, explosions. We should just cut all of this. Never happened. None of this happened. I think I've been too fixated on the explosive component of this project. I'm going to take it a step back and go to an idea that uses motor and fishing line. So the way I want it to work is I have my leg over here, I have a motor and a little spindle, kind of like a fishing reel. And when you apply power to the motor, that line winds in the leg, pulling it from out under the chair, thus collapsing it. So a very simple solution to what I'm making very complex. Let's test it out. All right, spinny thing test. Let's see how this works. There's fishing line here, the spinny disc thing, motor, 12 volts. Let's give it a whirl. Oh God, here we go. Oh geez. Oh, it's actually gonna catch it. Oh God. Oh Lord. Oh my God, stop it. No, stop it. That didn't work at all. Oh, it was supposed to go in the channel instead of just wrapped around. Oh, it broke too. Ah! Let's try this again, I guess. Rewind it a little bit. No! Damn it. Okay, so this design problem was I made the hole too big for the motor, so I'm gonna go redesign it, re-3D print it, maybe make it a little bit smaller, a little bit cheese wheelie right now, and then we're gonna come back, actually test it for real this time. 3, 2, 1. It worked. Definitely worked. It just kind of pulled the leg into the motor. So we just need a way to detach the leg after. Or maybe we should just try all 4. See what happens next. This is probably my safest idea yet. I really liked it. However, it does come with certain disadvantages. The first of which is when I was doing some testing off camera, I found that this motor just wasn't powerful enough to bring all 4 legs down at the same time. So I would need to source something even bigger than this, which then adds complexity. Not to mention, when it did actually pull all the legs out, guess what was right in the way of the path of the destructive falling force was this guy. So that would fall onto the ground really hard and really fast, which means I might have to design a cage around this and again make it more complex. I have one more idea to try out, not this one. I think it might be the best one I've had yet. Don't quote me on that. My last idea on the board is just an electromagnet. And I went back to the first idea but took away the springs because, again, I was just overcomplicating things. Keeping it simple, what I've done is I've put an electromagnet and a steel plate in each one of these legs, and I'm going to just turn on the electromagnet, have the part hold itself together like this until I turn off the power, in which that should happen. All right, let's test it out. I didn't hit the button. The power supply just unplugged itself. It works. Oh, I didn't even go 3, 2, 1. It just... Do it again. Round 2. Let's see it work. 3, 2, 1. I like this idea a lot. It's simple, it's practical, it holds the furniture together until power is taken away, and then it falls apart. And when you're looking for something to go wrong, as in the case of exploding furniture, that tends to happen in at least one of the joints, which sends a domino ripple throughout the rest of them, and it all just falls apart. And that's ideal. So let's apply this to our actual furniture. Exploding furniture, take 1. Let's try it. 3, 2, 1. Let's get the cat. But Captain, you can't use a power supply to turn it on and off for the final test. How are you going to make that work? Well, I think a circuit is in order. Basically what it involves is a microphone that sends a signal to the microcontroller, which then takes that and processes it. And it says, is it above a certain amount? Once it detects it is above a certain amount, all it's going to do is communicate with the relay on board that then deactivates the 2 electromagnets, which then collapses the furniture. So super straightforward. I'll demonstrate this now. If I tap the box here, it should deactivate this because it's going to be a very loud noise compared to the microphone. Voila. Thank you so much for watching. It actually really means a lot to me. If you like the content, please consider subscribing to the channel, as well as liking this video. I'm uploading once a month, so you can get similar content to what you saw today every single month for the rest of the year. Hope to see you back soon.